I have this fiber connection I installed few months back from one of the ISP provider available. The connection is good, but it is not always stable. So I decided to have another connection from another ISP provider available. And now I have two connections. I need to decide which one to cancel. And before I do that, I wanted to do a performance test on both the networks. So I created this application to record the latency and packet loss percentage using the ping utility. And I ran this application on two systems, one connected to the old connection and one connected to the new one. So what you're seeing on the screen are the result. These are the graphs that I plotted using the data collected from both the connections. At the left side you're seeing the data collected from the old connection, and on the right side you're seeing the data collected from the new connection. So if you see the RTT graph, the values are always higher than the new one, and the packet loss is too much. It's sometimes it goes beyond 20 percentage, and at one point it even hit 100 percentage. But in the new one, it never went beyond 4 percentage. These graphs really helped me to decide which one to keep and which one to be cancelled. So in this video, let me share my experience building the application, and I'm using Springboot, so it will be really helpful for those who are just getting started with the Springboot, as it covers some of its important features. Okay, let's start by creating a fresh project from the Spring initializer. Let me fill in these details. I'll name it as network status monitor. So I'm going to make it a Maven, and then I'm going to add the dependency called Spring Web. Let me add the Lombok as well, and I don't need any other things because I just want to run ping command only, so I will not depend on the third-party libraries. So let me go ahead and generate and download it and open it in the IntelliJ. Okay, first let's see how we can execute this command in the console. So the command is ping. You can give the host name, then we'll start sending the echo request. So the problem is it does not end in Linux operating system. I don't know about the Windows or Mac OS. I think it will send a limited amount of request, but in Linux you will have to explicitly cancel the operation. So I found a way. I just asked ChatGPT to give me a command which will which we can provide a count. Like if you provide this flag called -c and give the count, it will only send the request for request 5 times to the google.com. So this will be the command that I'm going to use, and it also give enough information, like the time is be round trip time, which is the RTT, and then we also have the information about how many packets were sent and what is the packet loss percentage, and it also records the minimum, average and maximum RTT. These are consolidated metrics, so I can use this line to extract information from. So let's see how we can execute this thing in the program, in the Java program. Okay, let's create a new function for this. I'm going to create a static function here, which I'm not expecting any return value. Just keep it in mind. May avoid execute ping. So first thing is I need a process builder. So this takes a command. I think it's a string array containing the program and its argument. So we can pass ping, can give the flag C, then the number of requests that we want to send, and at last we can give the host name. Okay, next we need a process. It should be surrounded with the try catch. Now we need a way to read the input of P. So for that, let's use a buffer reader. New buffer reader. It will take a new instance of input stream reader, and then we can get the input from the P. Now let's run a while loop. I will create a new string variable and then assign whatever coming in the buffer reader to this string. So let's read line by line, and then if it is not equal to null, I will just continue this loop. It's an error. Okay, I think we should be using parentheses here. Let's print out this S and see if it works or not. And let me call this function also. Execute ping. Okay, let's run this application now. Yeah, it is working and I started getting the output. We got the output. Now let's figure out a way to extract the RTT and other values from this output. Let's copy it and sequence from the ChatGPT. So I'm gonna paste this. Let's ask to make a pattern to extract RTT. Then packet transmitted, received, and packet loss. And to extract the average min max RTT. So let's see what the okay, now we have the pattern to match the RTT here, and other pattern which is packets to match the packets here, and then we have the consolidated data also. So let's start with the RTT first. Let's copy it and see if we can extract it or not. You can use the pattern class from the regex package. You can use it like this. In pattern.compile, you can pass the regex pattern, and then when you have a new line, you can use the matcher from the same package and give something called RTT matcher equal to, you can use the pattern dot matcher, then give the new line. Okay, to avoid confusion, let's rename it as RTT pattern. Now if there is a match, we can check if it has a find or not using this find method. Then we can extract the value. Group 1. The reason why I'm using this group function, because we have one mesh group here which is enclosed in this parenthesis, and that will be the group. So let's see if it works or not. Let me restart the application. Okay. It is working. I'm able to extract the RTT and RTT value. For now, let me do the other expression, I mean other patterns quickly, and then we will continue. The regex pattern we got from the ChatGPT had a minor mistake. So when I ran it again, it wasn't capturing the integers. It only captures the floating point numbers. So I think that is happening because we have specifically make the regex pattern to recognize the floating point number. So we can make the floating part or the decimal part optional by keeping it like this. So let's see if it works or not. Hopefully we will get a integer this time. Yeah, we got an integer. Now it got captured. Okay, so we are good. This is the complete logic, and I have formatted the output also. Now it looks like this, and now we have all the information. Now let's start designing our application and start implementing it. What you're seeing is a high level design of our system, and we will consider the output of ping request as a model. Okay, whatever values that we get from the ping request, and we will create a model called ICMP model. Then the whole the logic which I explained will be kept inside the service class in this function execute ping, and this will be responsible for extracting the necessary values from the ping output and then creating a model out of it, and then pass this model to the repository and then persist it in the database. And I want this to continuously execute ping function in the background, and for that I can use the task scheduling feature of the Springboot. This will run every 5 or 10 seconds. We can provide a number, and I also want to expose one endpoint so that we can use the ICMP model to plot a graph or any kind of visualization. So this is the whole idea. Let's start implementing it on the Springboot application. Okay, let's create a model class first in the model package. I'll call it as ICMP model. Then let's copy the values from here. And we'll add some annotations. These are coming from the Lombok, and we'll also add the builder annotation and also the toString method. Let me import the instant class also. So we have our model class now. Next, let's create a service class. First we will define a interface in the service package. We'll have a function called execute ping. This is where the logic will be placed, and we also need one implementation for this. Okay, let's implement the service and let's override the method. Okay, now I can copy the logic here in this function. Okay, now let's create one model out of this from the extracted values. So I don't need this system out statements. Let's create a model. So let's use the builder. First let's populate the provider name. For now I'll just keep a name, provider name, then we will also need the timestamp. Instant dot now dot build. Okay, now we don't need RTT values, I just need the consolidated ones. So let's start adding the consolidated values and the packet information. So model dot set packet sends. I can copy this thing, and this is going to be an integer, so I will just pass it. Then we will make the set packets received, so that is there in second group. I'll do the same, I will just pass it to an integer. And the percentage will be a double value, so I will use the double class to pass it to a double, and this is there in the third group. Okay, now we have the packet sends, received, and the percentage. Now I'll do the same thing for the RTT. Set average RTT, then set max RTT, sorry min, and max. So these are all double values, so let me just copy it from here. So first is minimum, that is the group 1. Second group is for average, let's do that, and 3 is for the maximum. So now we have the model ready. Let me just print it out. Since I have the toString method, I can just print the model, then it will just display the object, and I don't need this system out statement. Okay, and let's see if we can run this from the main function. Instead of calling this, I can create a new ICMP service, and then it should be static since the method is a static one. So the service dot execute ping. Okay, I have started the application. Oh, I think I kept the system out statement in the wrong place. Let me refactor that. Let's take it out of the loop, and let's run it again. Okay, it gave an error. Let's see what it is. So no match found. It's in number 42. Yeah, okay, I used packet matcher instead of this consolidator. Let's restart it. Okay, let's give it some time. There you go, we have the ICMP model, we got the timestamp, we got all the information that we need. Okay, let's create a scheduler for continuously execute this method in the background. For that, I will just create a scheduler class in the scheduler package. And I need a function, public void perform task. Okay, I want to call this function in the ICMP service, so let me auto-wipe the service. and call the execute ping. Now I want to add some logs in the console, so let me use the SL4J and add a line log.info performed task at, and I will append the time. Okay, now we have the function. We also override the service that we want to call. Now the most important thing is we have to annotate it with scheduled and use the fixed rate and give the seconds in milliseconds. So if you want to run it for 5 seconds, then give 5000. This will run this function every 5 seconds. And we should also let the Springboot handle this class. So if we annotate it with component, the Spring will manage this bean and then take care of executing this task. Okay, now one more thing we need to do in the main class, that is network status monitor application, where you have annotated it with Springboot application. We also have to add one more annotation called enable scheduling. Okay, now we don't need these things. Let me run the application and see if it works now. Okay, first task is performed at 11:8:31. So the next task at 36 and the next task at 41. So there is a 5-second gap in between, so the scheduler is working fine. I tried to run the same code in a Windows operating system and turns out it doesn't work in that system. So I tried to debug the issue and then found out that the command and the output we get from the Windows system is totally different from what we get in the Linux. So that one thing is certain here, so we have to figure out a way to configure all these patterns and provider names in such a way that it should be configurable. So for that we have a application.properties file. In this file you can provide the properties and its value in this file. So let me show you how we can do that. Let me show you one example here. Let's take this provider constant. So let's create a string provider, and what you can do is you can use the @value annotation, and inside the quotes $sign, and inside the curly braces you can give the property name. Okay, and you can copy the same property to the application.properties and give a value to it. So provider, let's say Geo. Okay, now let's see if it works or not. And also let me change the string constant to the variable provider, and let's see if it works. As you can see, now the provider has been changed to provider Geo. So that means this particular value is coming from the application.properties file. So that is how you can inject values from properties file. And let me go ahead and quickly declare this RTT pattern and other constant commands and everything in the application.properties file. The code has been refactored and I have removed all the hard-coded values to the application.properties file. And I want to show you one more thing, like how to send a default value to this variable. So if you see here, I have kept provider : provider ID. So this is going to be the default value. So first it will try to find a property name provider in the application.properties file, and if it fails, then this particular value will be binded to the provider variable. And if it does not find any value here or in the application properties, then it will not start. And in the next section we will see how we can set up the database and rest of the concepts. Thank you.